All right, so here we are with the first stream. I want to start off just by saying thanks. This is also going to get turned into video content since I'm sure nobody is really going to see this, but I wanted to start off getting the stream and everything good. If you don't know me, my name is Josh O'Brien. I am a tech nerd out of Wyoming. I have done a whole lot with my career as far as virtualization, hyperconverged early with Nutanix, sold a lot of Cisco, deployed a lot of UCS and Nexus in the early days. And then for the last 8 years, I have been a leader and manager in a Silicon Valley company, Sauce Labs, and then was recently got laid off with about 50% of the rest of the company over the last year in 2023 and looking for the next thing. But I've been wanting to do this for a long time. Been wanting to do content and figure it out, and I wasn't really sure what my content should be. Like, not a TikTok dancer, and I'm not good enough with my drone yet to be doing like crazy drone content. But I am pretty good at tech, and I think there's a lot of interesting things going on right now in the market, and that includes, Broadcom buying up a lot of different products and changing how those products work in market. I was at Brocade when they bought Brocade, and actually I was laid off from Brocade after about a year, right before I went to Sauce Labs. That wasn't quite as crazy as this has all been in 2024, but they make a lot of interesting changes to companies when they go in and acquire them and take them over. They change business models, they change pricing models, and we're seeing that right now with VMware. They have killed a lot of the partner stuff, and I know a lot of partners are scrambling to figure out what's next. I know they've killed a lot of products. They've sold off a lot of the desktop portfolio, and we know that they have changed a lot of the pricing. I'm seeing crazy pricing coming out of very small customers and very big customers. And that's led a lot of people to say, what's next? First off, I'm not anti-VMware. I cut my virtualization teeth on, forget the name of it, but the pre-ESX product that was free way back in the day. I deployed lots of ESXi. I ran it in my own personal labs. I ran it for customers. I did big vCenter deployments back in the day. And then over the last 8 years, when I was at Sauce, we didn't use any primary platform until we grew into Kubernetes and we deployed that for our control plane stuff. But we used a lot of different virtualization technologies like QEMU and virtualization for real devices. But all that's moot. But I kind of got a different experience. And we had talked multiple times, should we go VMware? Should we go OpenStack? Should we go some of these other products? Looked at a bunch of them over time, and it just never really came about there. But what it did give me a perspective for is there's a lot of different ways to do this. And a lot of people have done that, whether it's XCNG, whether it's Proxmox. There's other cloud products and virtualization products that people have used. And I want to just kind of play with that. I want to see what's out there. I want to see what we can do to help people figure out what's next and maybe what a path is. So what I've been doing is I've been standing at my lab again and haven't had like a really functioning lab for almost 7 years. I've just been busy with other stuff. But what I'm going to do is I'm going to pop this up. This is kind of what I started with. And sorry my face gets so dark, but I am not the priority here. What we have here is I have a 2-node Proxmox cluster. PVE1 is my worst of my servers, and it's really loud. And if you're hearing a bunch of noise in the background, that's probably PVE1. And long-term PVE1 is going to be a cold backup for me. But I do run loads on it. As an example, I can take, say, Pi-hole 2 here, and I can migrate it up, and we'll migrate it. And there's a lot of interesting things that I can go into, and we'll talk about, one, how I set up the 2-node cluster and why. And then beyond that, the things that I did in order to make it usable, the things I did to what I've used it for. It's been up. The cluster has been for about 2 months now. And what's interesting about this is I started doing it from the perspective of, oh, let's just kind of figure it out. Let's understand how Proxmox works. What I've gotten to the point of doing is I want to show people how we can really use these products in real business, whether it's mid-market, enterprise. Enterprise has its own set of challenges, but definitely in mid-market, there's really good opportunities for you. First off, Proxmox is 100% free. They have paid support for it. It's not unreasonable at all. They have supported, losing my words here, they have supported repos. There we go. Supported repos that you can actually use. I'm not using those right now, but they're easy to set up once you pay for it. So if we go into a host and we look for repos, you can see I'm on the no subscription version of both Ceph and for the clusters. There's full enterprise repos for these that are, I'm assuming, better validated, better tested against clusters. I'm running on old gear, like the PVE1 and PVE2. I think they're called Dell TTY24 or 24TY servers. They were cloud servers that were OEM'd to cloud providers like 12 years ago or longer, and then they hit the market as used. And then my other two servers are a Dell 510 and a Dell 630. The 510 is my big storage server that we'll talk about that I currently have Proxmox backup server running on. And I'm running, about 22 terabytes on it. They're just 2 terabyte drives, spinners on it, SAS drives. I got them cheap when I bought the server from a used house down in Salt Lake. And then the 630 is kind of the more powerful little box. But that's all neither here nor there. My point to all this is that we can spin up really powerful, very capable clusters at a very low cost, especially from the software side. The software side is literally free. Do they recommend running production on the free? Absolutely not. But it's there. And as you can see here, this migration is going on. It's taken quite a while right now. They're 80 gig volumes. I've got some interesting things going on in the background, but we'll talk about that when we dive into why I did things the way I did. Today, again, just an introduction, why I'm doing this, what I want to learn from it. The other thing is, over the last 8 years, I've not been super hands-on. First year or so, really hands-on the network side of what I was doing. But over time, it just got to the point where it was better to let other people do it. That's what I'm good at. I'm good at going in, kind of slapping Band-Aids on infrastructure and challenging environments, and then bringing teams in who are the true experts to go in and take my triage and turn it into highly scalable, highly stable environments while I manage and grow and do the other things. Enough about me. Let's talk about some things. So first off, I'm going to bring up here, because this is the important part. I believe that fundamentally when you're building out stable systems, you have to start with a good roadmap or a good set of plans and a roadway. And the roadways in technology are the network. I grew up in networking. I did a lot of network sales over the years, deployed big schools, big data centers, all that stuff. And the thing I learned out of all that is, while there are a lot of really cool bells and whistles you can do on network, you shouldn't use most of them. There are cases where you have to solve a problem. But at the end of the day, you need very stable, very capable highways for your data to roll on. So I'm at my house. I'm actually at my shed office right now. The servers are behind me in some racking right now. And then I have an underground path from the shed that runs into the house that we put in. And then that runs into the back of the garage. The garage runs into our laundry room, which is our kind of core data room where our APs and everything go from there. I've got some other things I could show on the network. Doesn't really matter, but we use Mocha adapters because the house didn't natively have Cat 5 or Cat 6 in it. So we ran Mocha, and we did Mocha home runs to the boys' rooms, to the living room, to other places where we would need higher capacity. And we're running a gig download from the internet, and I want to say 50 gig, 40 or 50 meg upload. And that's all through All West, who's our provider out here, through DOCSIS cable connections. So with that said, up here at the top, you can see my cursor. What we do is the internet comes into our USG Pro. Our USG Pro acts as the core for the network right now. It's not optimally what I would do, but it's how the network's set up. We were all UniFi here at the house until I implemented the shed, and then I just didn't want to go buy a bunch of other UniFi gear when I had Cisco gig switches that would work absolutely fine, actually very well for what I do. Optimally, back when we lived in Ohio and I did the big NetApp and virtualization lab in my basement when I had a NetApp cluster down there, it was all Cisco. Cisco routers at the edge, Cisco 3560s, and HSRP for the core, Cisco, I think 29 somethings as L2 down to the devices. I had built out a small little kind of enterprise Cisco footprint, but that's what I did back in the day. This is, a little bit more slapdash and a little bit mixed, but that's all right. You run into that a lot with technology. School districts that I've been in have been Juniper, Cisco, HP, no-name Chinese branded switches, and that has its own set of challenges and interesting things, as does UniFi mixed with Cisco. As an example, I'll switch back over to the UniFi footprint real quick. If we look at our UniFi footprint and we look at the network, not so much the host, but what you'll see here is that you get this really cool map that comes down from the UniFi USG Pro. It comes down into the US8 that was kind of the L2 core of the network before. It can do pretty pictures with things like showing kind of traffic volumes. That's neat. I like it. But what it doesn't do is it doesn't conform to some standard mapping like LLDP. The devices talk LLDP, which I'll show you in a little bit, but they don't then find their way into the map. So you end up with interesting things here. So you end up with the USG going into this and going into my US8 switch, which then breaks down into all these Mocha switches that we have. These are all the Mocha switches right here. So I'm trying to see. So this is one of the boys' rooms. This is the kitchen on Mocha. This is another one of the boys' rooms. Because they're doing video editing and they're doing their own streaming things and gaming and all that. So we just wanted to have hard wires. And then we have an AP coming off that. We have an AP coming off our kitchen one. And then you get all these other things. Now this is interesting because I'm pretty sure I know for a fact this is one of the servers. And the server is showing this coming off the US8. It's absolutely not. It's actually coming off one of the Ciscos. But what you don't get is you don't get a good view of where the Ciscos are in here. Matter of fact, because these UniFi devices are not all connected directly to each other, they're not able to map correctly. So what you end up with here is you end up with, see this basement switch? This is now out in the shed with me. It is what this computer that we're talking on, or that I'm communicating with you guys on, is connected to. It's a little UniFi 5-port gig PoE powered switch. So I plug it into my Cisco device. It powers it via 802.11af, powers the switch up, and then it gives me multiple ports under my desk. I don't really need that because I literally have, the way I wired the shed, I have 8 Cat 5 gig connections right next to me. But I in the house I didn't have that, so I've just kind of kept it, and it gives me kind of a little lab bench where I can quickly plug things in to the local VLAN that this is on for setup or for testing or whatever else. And that's what I'm connected to right now. But it's not connected to anything. It's just this device hanging out in the middle of nowhere. And you get the same thing with the USW aggregation device, and you get the same thing with this AP. Why do I say all this? I say all this to go back to the diagram that we have here, which is this. So we come in from the internet to the USG Pro, which acts as the core for this network and does all of our routing. And you can see here all the VLAN gateway addresses that we put in. And then it jumps to this Core 8 device, which is that one that we saw in the network diagram from UniFi. And then that comes across a 1 gig .1Q trunk to a 3560G in my garage. So cable passes through the wall, comes to the garage, and then the cable passes through the back of the house and then underground to the shed. And then I use the two 3560s to create this kind of WAN link, this .1QL2 trunk that I can then transport out to the shed. Will I do this long term? Probably not. Long term, I'll probably eventually move everything out to the shed network or out to the garage network wise. Move the other 3560 to the shed. We'll do like an HSRP data center out here. But right now, this is what we're doing. The other interesting thing about this is that there's a 10 gig storage switch right here. And we could see that switch, again, hanging off on its own right here. And hanging off of that 10 gig aggregation switch are all of the servers that we're going to be using for Proxmox. And the reason for the 10 gig is for the storage and backup and replication. So I was doing all of that on 1 gig initially, actually off of this this US 8 UniFi switch, and it just didn't work well. So what we're doing here is we're laying a framework. And that framework is VLAN 1 for management. Any of my networking people are immediately like, no, don't do that. The problem is I've tried to move my management all over the place. UniFi doesn't like moving management around. UniFi also doesn't like moving the root wireless network around. It likes it on VLAN 1. And I'm sure there's ways to fix it. I've got one or two of the devices to pop up, but it causes lots of connectivity issues, lots of communication issues. The other interesting thing is that I'm not running a standard unified network, at least what most people do. Most people will have like a cloud key right up here off the USG or off this switch. I am running my cloud key type thing over here. I'm actually running a server in Proxmox. Can show you guys that. So this UniFi dashboard, this UniFi admin, all of this stuff that we're doing in UniFi is actually running right here. And it is this VM that runs all the way over here on this network. So it's actually talking off the production port of this 3560G here in the shed. What's interesting about that is anytime you make any changes to this link that causes a communication issue anywhere in this path that isolates the shed, you lose the network management. When you lose the network management, the APs don't like it, a whole bunch of other things don't like it. That's just to say I've got a little bit of a constraint here. My long-term plan is to actually get like one of the Dream Machine Pros that'll do 2.5 and 10 gig and move it to replace both the USG Pro and the Core 8 here when I move it out to the garage. Like I said, unemployed right now. So we are making do with what we have. We're doing cool things. We're learning cool lessons. And that isolation of a network controller is an interesting thing to talk about, because we're talking about this is effectively kind of a software-defined network config with a controller that controls all the config. Once you have something like the Dream Machine and the current Dream Machines, it can control WireGuard, VPNs, and lots of stuff. And even on this one, I can do VPN termination right off the USG Pro. And we can build out a infrastructure of VPN connections from here to data centers to other offices. Actually had another office across town for a while and ran a VPN connection between my two USGs that I had. I had the smaller USGs at the time, but I would run a VPN connection back and forth from there so I could access stuff at the house or I could access stuff at the office. And they were just both on the same cable provider and VPN and all that. So All that said, you've got a bit of a software-defined network going on here, and I know people are going to say, it's not really software-defined. Sure, it's config-defined. It's not, you don't have NFV components, and you don't have things being, like dynamic decisions being made. But at a high level, you have a controller controlling the network, making decisions, designs for it, showing you logging and all that stuff, lightweight SDN. And when you're dealing with something like this, if you look at this as like a 1 gig WAN connection, L2 WAN connection from a carrier, or your own private fiber and an infrastructure, you're also controlling devices across your WAN into your bigger enterprise, so you have a bit of a controller-based enterprise. There are ways to do redundant unified controllers. I haven't done that, and I think that's more from the perspective of redundancy at the core. I also know that I could segment these two things right in half here and have a controller over here controlling everything that's UniFi, and have another controller over here that's controlling everything that's UniFi, and then you have multiple sites, and that's probably the optimal way to do what I'm doing here, but it's not what we're doing. And what I want to simulate with these labs is the ability to not only create solutions and interesting things, but to solve problems. Very few environments are greenfield. Most environments, even greenfield, come with a set of requirements, and you get into them and you start deploying them, and then something doesn't work quite right, or you've got to adjust and you have to adapt on the fly. And I've been doing that for years and years and years, whether it's turning up U.S. Playing Cards' new site when we moved from Cincinnati to Kentucky. Lots of requirements, and we get there and we realize a lot of those requirements aren't really compatible with the environment that they've then architected, then had us deploying. So you kind of just have to adapt and move on the fly. Same things with one of the big school districts. They had 30-some sites, mixed vendor, had no budget for new equipment. So we were shuffling things like 6509s that have been deployed at newer schools that were way too big for new schools. We were bringing them back to the core of the organization. And then what we had piles and piles of the old 3500 L2 switches. And then we had 3560s and 3550s that we were using for L3 at the school edge. So we were taking this school from an old serial WAN connectivity to Ethernet connected and gig between all the sites and routed between all the sites, which solved a lot of problems. But throughout the whole thing, we had to make a lot of decisions. Some of them were good, some of them were bad. But that's what we're doing here. That's kind of my point. We're building out something. We're trying things. We're solving problems. We're stumbling across landmines along the way, like my controller being across my WAN. I've done a lot of talking around that. Typical for me. One of the reasons I think that this stream will be interesting for me, because I can just talk. The video content will chop up more. But as far as what we have here, so let's go back to the network. So we're creating multiple VLANs. A lot of people are saying this is overkill. But what we're doing is we're doing VLAN 1. VLAN 1 is going to be our management VLAN. Our switches currently aren't on it. Our Cisco switches aren't on it. All of our UniFi stuff is. Then we're going to do a primary user VLAN, which is where all of our wired hosts are going to connect. So all the ports for my PC, for Xboxes, for all the things that are wired in the house are going to come into this this VLAN right here. And then we're going to do a primary Wi-Fi VLAN. Again, all the primary house stuff. Then we're going to do guest, and then we're going to do IoT. We don't have a ton of IoT stuff in the house, but we have more than I thought we did when I started kind of building things out. And I just want to make sure that we're isolating IoT stuff correctly, and that we can prevent where it's going and what it's doing, and we can make sure that it's not communicating a bunch of stuff outside of the house that we want. The more interesting things to this is that we're going to do a VLAN 10 server production network. We're going to do a VLAN 11, which is CoreOSync, which is the cluster management component of Proxmox. And we'll talk about all these in a minute. We're going to do VLAN 12, which is migration and replication. And then we're going to do VLAN 13, which is storage and Ceph, and I'm going to include backup in that as well. Primarily because I got this aggregation switch. When I started doing all this, I should jump back here. That's the network. That's the roads we're building. This is the physical path. This is the logical path. This is how we're going to break things up. We'll talk lots more about this as we go on. Then we're going to go up to what I did to start with Proxmox. Very basic diagram. This will have some alignment with what the network stuff that we looked at, but you should mostly ignore the networking. The internet down here, the USG Pro, the core switch, which is that US8 that we talked about. And then we had the two servers. We had PVE1 and we had PVE2. PVE1 and PVE2. And then we had their public interfaces, which were on that VLAN 1. But again, that doesn't matter because that's just what existed at the time. Initially, when I did all of this, I didn't have this connection or these connections. I just had PVE1, and then what I did, I actually had just PVE1 up as my first server. Decided I want to do this as a cluster. I want to see what this looks like, high availability. How do things move? How do things warp? How do we make things valid in a bigger environment? And to be honest, as I was playing around with things at the house, it was frustrating as I started relying on a service like Pi-hole as my primary DNS, and I would shut the box down, and then I didn't have Pi-hole, and it'd just be fallback, and I couldn't do name resolution and all that type of stuff while we were doing an upgrade or a reboot on a box. So I'm like, all right, let's try this. And it became just like any other enterprise, how do we make these services resilient? Or any other business trying to make services resilient. A lot of people are saying this is way too complex for home. Totally agree. But this is also kind of fun for me. For years, I ran, like I said, back in Ohio, I ran the house like I would have ran an enterprise with outage windows and everything. And, didn't really tell the family about it, but it's what I did on the back end. And when it was down, I would get the call about it. The downside of that is when it's down and you are in California, because something goes wrong, nobody in the house can fix anything. So you've got to put things in place for that too, but we'll talk about that later. So what we did here is I had CoroSync, I had storage, I had replication, which is vMotion. Replication, migration. I called it vMotion in this because I really didn't know the terminology for it yet, but it's migration inside of Proxmox. And backup and everything was all on this public interface of 1 gig. It did not work well. As soon as you started pushing a migration, the vMotion component, for those of you who are VMware, you would flood out these links, and then CoroSync died. And if you've not ever done anything with CoroSync before, CoroSync isn't a large volume a bandwidth. CoroSync is just highly required. Like there's data going back and forth, and we can dive into the data that goes back and forth later. But if the two devices cannot talk via CoroSync because they flooded out, because you've not rate limited correctly, because you haven't isolated the network, then the cluster goes unresponsive. When the cluster goes unresponsive, then your migrations get goofy, everything gets goofy. And it was really to the point that I fragged the 2-node cluster so bad that I had to break the cluster. I had to go into CoroSync configs. I had to manually make changes in the CoroSync configs, which is kind of suboptimal, as we'll build things out later, and I'll show you that clusters are really easy to set up in Proxmox. But as with anything in tech, if you don't understand the underlying technology, or you don't have somebody who understands the underlying technology, you can get into a real problem. And I had some experience with CoroSync for my 8 years at Sauce, especially in the first couple bad years. I knew it was really touchy, and I knew that you had to treat it with kid gloves and give it priority resourcing if you wanted it to work right. I didn't do any of that, failed horribly, and then I had to go in and I had to manually adjust things in the configs to make all this work again. So with that, what we did is I jumped online and I said, okay, I want 10 gig. I know 10 gig is still a primary use case, and I know we also have 100 gig and 25 gig now, but there's also 40 gig. So I started looking around eBay looking for what the cheapest cards were that I could get. And I'll be doing some blog posts on staticnet.com about what all is in the lab and stuff, but I'm not going to do all that here. And then I'll eventually probably link out to that stuff once it goes to YouTube and everything as to what all the hardware is in the lab. But I found some old, I don't even remember what they were off the top of my head. It's whoever NVIDIA bought on the network side. I'm just blanking on it right now. But I found some of their cards that were 25 gig, and they were really cheap compared to what I thought they were going to be. And then I went and looked at 40 gig, and 40 gig was about the same. But 40 gig was QSFPs, and 25 gig was SFP28s, I think. And the cool thing about SFP28s that I didn't even fully grok at the time was that SFP28s are backward compatible to SFP pluses, which are 10 gig SFPs, and SFP pluses are backward compatible to SFPs, which are the old 1 gig SFPs, and so on and so forth. This worked out really well in building out the current state of the network. But what I didn't really think is that as I was looking at QSFP switching, you can get 40 gig switching pretty cheap, like hundreds of dollars for a pretty good device, especially for home labs. And I thought, well, if I can get 40 gig QSFP switches pretty cheap, I should be able to get 25 gig switches really cheap. No, that is not the case. 25 gig switching is kind of in that sweet spot right now, where it's SFP component based. It's not QSFPs. Most of the hardware is being built out on that now. 100 gig ports have breakouts to 10 and 25. All that really cool stuff for data centers, but not great for a home lab. So when I started getting into it, I realized that if I wanted to get a 25 gig switch, my best bet was one of the MikroTik ones. And I still think for what I needed, it was close to $1,500. Not outrageous, but again, currently unemployed, currently looking for work, and I'm building out a home lab. I'm not building out a big global enterprise or even a small data closet for a business. I'm not making money on this. I'm learning and building content for all of you. So here I am with these 25 gig NICs. They worked really good right here. This gave me a 25 gig path for vMotion across these, and they're 2-port NICs. I was able to do DAC cables, direct access cables, so they've just got the SFP28 hardware on the end, solid wire, plugged them in. I think I got 6-footers, so I had plenty of room to, no matter what I ended up doing, and I connected them across. I then had a really dumb 1 gigabit switch, just some piece of junk 1 gig switch that I had sitting around, and I created that to give myself a CoroSync network. So now what I've got is I've got a public interface that's 1 gig that I'm able to hit the management interfaces, that I'm able to give addresses on for all of the virtual machines. So if we go and we look at one of the virtual machines, so if we look at Homer, this is the dashboard based on a product called Homer. This is running on that interface that I just showed, that public interface, that VLAN 1 interface, as it sat at that time. So on this interface. And this is the bridge that allows us to do multiple VLANs and everything across this, but we are just using the primary house network, which is VLAN 1. We then created this 10.1.3, which gave us storage, replication, and migration at 25 gig, and it was great. And the biggest challenge with that still is great. It's a little bit different wiring, which I'll show you in a minute. The downside to it is that the hardware and the way that we had the stuff configured on Proxmox is that we have everything configured in ZFS. So we have a single ZFS pool of 3 disks of 2.99 terabyte on these hosts. And that volume is where all the storage for everything sits inside of this cluster on the 2 nodes right now. It's ZFS local. There's no Ceph involved, even though I messed with Ceph, so you might see some Ceph references, but there's no Ceph going on. It's just ZFS locally, and it's, I think, ZFS in ZFS RAID 0, I think. and I can probably even look at that. So if we look at details here, so we have health, online, zpool. Yeah, I don't know right off, but I'm pretty sure it's all just in ZFS RAID 0. And then when you go up to the summary, you'll look, and what we end up with is when we start really diving through things, you don't have too much of a memory problem. We're pretty good, especially when we split the host between the two servers. We're good on memory. Server load, though, starts impacting. And server load's kind of a generic term of all the different issues. But what we really start getting is we start getting I/O delay when you're doing 25 gig of transfers across this path right here. You would start getting serious I/O delay. So while we got much better throughput than we did on a 1 gig shared interface that we were sharing all the services with, we didn't hit our cap of 25 gigabit per second. We were well below that. And again, not a big deal. Home lab works fine for me. Things move a lot quicker. Minutes of transfer and migration over hours and breaking everything. And the final component here is the CoreOSync network. That was critical. I have not, again, had a problem with CoreOSync since making this change. So I think if there's a takeaway here, you at minimum need to do 3 interfaces for your Proxmox cluster network. You need a public that your services go out at minimum. In this case, it's both the management facing front end to Proxmox and the clients. That's not optimal. We'll fix that later. You need a storage replication backup network that is a high bandwidth network, 10 gig at minimum, and we'll talk about that because that's what we're running now is 10 gig. Off 25 gig next, but 10 gig. And then finally, you need this dedicated CoreOSync private network. That network doesn't need to do anything but talk between the servers, but it can't be messed with. It has to be rock solid stable, no questions asked. And there's a bunch of different ways to do that. You could do split networks in some sort of HA network configuration. We're not going to go into all that. I'm talking more at just kind of the high level here. We might at some point, but not now. But quite honestly, a pretty standard Cisco switch, even a pretty standard dumb 1 gig switch is going to be plenty for this. In my case, I'll jump over to what we're doing as the final, and we're over 30 minutes now, so I want to start wrapping this up. For any of you who end up watching this later or whatever, thanks, appreciate it. There's going to be a lot more of this content now that I've got my rig set up and I've got kind of things to a state. But I appreciate you watching and hope you'll rejoin us for some of the live ones or something. So anyways, to start wrapping this up though, this is roughly what we have now. This is what our goal is. So what we have here, and I've gotten rid of all those other networks, wireless and all that. They don't matter for what we're trying to do with the cluster. What we have is we have our public VLAN, so VLAN 10, that will be stretched across all of these. We have VLAN 11, which is CoreOSync, which I will stretch across all of these. And then we have VLAN 12, which is migration and replication, and VLAN 12. Oh, sorry, this is wrong. This should be VLAN 13 and VLAN 14. I've got some documentation stuff to clean up. These are going to be isolated to the storage switch. And this storage switch is a unified 10 gig 8-port aggregation switch. And this is where kind of the cool thing came in, where I mentioned earlier the SFP28s, SFP Plus, and the SFP standards are all interconnectable. So what happens is if you have a 25 gig SFP Plus or SFP28 interface and you plug it into an SFP Plus 10 gig port, it'll show up. The devices will recognize each other. They should. In my case, they did. And it recognized the DACs and said, oh, you're SFP compatible, and you do 10 gig. So between the card and the aggregation switch, the card said I can do 25, the switch said I can do 10, and they agreed to do 10. So I'm using cheap 25 gig SFP28 interfaces in all my servers, so I can eventually upgrade to 25 gig in the future if I want. And they all rate limit down to 10 gig. And that UniFi switch is like $300. So it's radically cheaper than any of the 25 gig. As a matter of fact, I was down in Salt Lake yesterday and was looking on Facebook Marketplace, and there was a loaded Cisco Nexus 9000 switch. Every interface loaded. I don't even know what all the optics and stuff were. $600, all 10 gig. So for $600, I could add a 48 port 10 gig for double the price I had for my 8 gig, but not buying more stuff right now. So you can get 10 gig really cheap, and all this stuff's backward compatible. So with that said, we're going to build out a 4-node cluster. We have all 4 servers. The 2 current ones we're running. A new Dell 630, which will be the cluster primary, and is already running Proxmox. That's the other thing I'm not going to do. I'm not going to be showing how to plug in a USB and how to go through a menu to do default setups on stuff. There's a million videos out there that are probably better quality, set up better for screen capture and stuff than me. I'm just not going to do that stuff. I'm more interested about, okay, how do we take it from like configured and root password on it into being a functional service. Then the other one we have is the Dell 510. And the Dell 510 I mentioned is our backup server right now. That is going to be critical for our migration process because, like I said, I want to show what it takes to migrate into these things. I want to show what it takes to take an ESXi VM that's running and then migrate that into Proxmox, because Proxmox now has a from ESXi host migrator tool that you can actually just point at ESXi and move over. But in this case, I want to show, okay, I had a single node, I turned it into a crappy cluster, and now we're going to take that crappy cluster and we're going to migrate all of those services over into a real cluster. And we're going to start by migrating all those services over onto a single node. Then we're going to burn down the 2 existing cluster nodes because I don't have an unlimited data center of hardware. Normally you would just build the new cluster and migrate the services to it. And then when it's all said and done, we're going to burn down the Proxmox backup server. We're going to turn it into the 4th node in the cluster. And then we're going to reinstantiate a Proxmox backup VM with direct access to the bulk of the storage on that, and we're going to pin that VM to the Dell 510, which is the big storage node that I have. And then we'll do all of our backups from there. And is that best practice? No. Best practice is you'd probably have 2 Proxmox backup servers, and then you'd pull backups between those. That way you could always recover. And Proxmox backup server is another interesting thing. It's a free server. It natively integrates to Proxmox to back up all your VMs and allows you to dive in very deeply into the host down to the file level and do recoveries or do a full recovery into a new environment, which is what we're going to do for our migration. Our migration is going to be a backup, a reinstantiate while the service is already running over here, turn the service up here, turn the service down here, and we'll have very minimal downtime. And that's another big part of just understanding enterprise technology and enterprise environments, or even smaller environments. You don't want downtime. You want your services to be as resilient as possible so you have very little impact. The other thing is if you design this stuff early this way, it means that your change windows and your maintenance windows are never perfect, and if they are, you should look for where the gremlins are going to bite you. But it means you can minimize those outage times. You can minimize those middle of the night and weekend migrations if you've got redundant services. Things aren't that big of a deal if you move a redundant service, bring it up, validate that it's there, and then migrate the other service even in the middle of the day. Not necessarily a huge proponent of that, but possible. And then final aspect around this, I said that we are going to have migration and replication. We're also going to have storage and Ceph. So what we're going to do in the new cluster is we're going to do hyperconverged. I don't know how well it's going to work out. I've heard mixed messages about Ceph. I've had people say stay away from it. I'm a big fan of hyperconverged. I think I mentioned this early on. I was, I think, client 5 for Nutanix when I was the CTO of Telemed. Literally saw them present at a tech field day. They left stage. I called, and I actually got one of the presenters who had just presented at field day. He's like, how did you hear about us? I'm like, I'm watching the tech field day stream. I want your product now. And they were like, we're not really ready to sell yet. I went, you presented, let's figure this out. So I think we were client 5. I love them. Still love them to this day. They've grown amazingly. But more importantly, I like hyperconverged. I think the idea is smart. Bring your compute, your memory, and your storage all to the same platform. Ceph gives us that. Ceph gives us that Nutanix-like convergence, and then striping of the data, striping for lack of a better term, replication maybe across. And then what we do is effectively, as we do migrations and stuff, the data is already on the disk. So doing a migration is just about, replicating the instance over, connecting it to the data, and then doing the memory dump over, and you're done. So our migrations should get way quicker. Migrations aren't time-consuming now, per se, but they take a little bit of time. I won't talk a whole lot about it, but right now I'm doing ZFS to CFS local synchronization or replication. So if that replication is up to date, which ours isn't because we've had the servers down and doing things, replication is minutes to seconds. Even right now we're a ZFS replication. But with Ceph, it should be much faster because the storage volume should already be there. We also have benefits of dedupe once we go to Ceph. That'll be nice. Doing things like almost all of our hosts being on Ubuntu for what we're doing. A lot of this stuff will be deduplicated. There's a lot of things that are replicated in here. The other thing, and then we're going to close out because if I look at my time, we're heading towards an hour, and I don't want to do that to everybody. But what we're going to do is these services all here are all meant to replicate what a actual enterprise would have to some extent. So example, Homer, this is a service catalog. This is a dashboard for the home lab, but it's a service catalog. And service catalogs are common these days. The Unify is the controller, like we said, back to the software-defined networking, software-defined control, controller-based network stuff. Netbox is from Netbox Labs. My friend Stretch built Netbox a long time ago and is building a company out of it now. It's a way to track the state of what you want your network to be. So all these diagrams and networks and everything that we're putting in are actually going to end up in Netbox. And Netbox is going to be the source of truth for our network. So when we start doing automations and playing with other things, we'll use that as the core truth. Pi-hole 1 and then down here Pi-hole 2. Actually move Pi-hole 2 up to PV1, told you earlier. The migration, the Pi-hole stuff is going to be our DNS. It also does a bunch of blocking of advertising and stuff like that via DNS, but at the core, it's our DNS server. I'm not sure how long we're going to stay there. It works for now, but I've had a bunch of issues with it, especially once we switched it to behind our Kemp load balancer. But we'll figure that out. TrueNAS is acting not as necessarily our NAS for the network, but it's acting as just volume shares. We needed to have an ISO share to share between the cluster, and that's how we're providing that, is via TrueNAS. AppC is app caching for all our updates for our repositories for Linux. That just saves us bandwidth over time. LibriNMS, that's a network graphing and monitoring application. Ansible Control is the server that I run all of my Ansible changes in Terraform from. Docker host, it's where we're running Docker services. That's an interesting thing about Proxmox. Proxmox does LXC containers, and that's what Homer is running on. So our Homer is an LXC container, but if you want to run Docker a host specifically, I have to have a dedicated Docker host. Kali Linux, we're going to play around with some security stuff. NetLab, that is network labbing for different components. We'll dive into that later. But this would be something that you'd use in an enterprise to mock up environments and to lab out changes. ImageMaster is the server that we're going to use to build images around. Different thing. VIA OS is via the old Viata OS. There's still a lot of really interesting things there, and I was talking to one of the guys who's got some projects around that the other day, so I installed it. Again, another NFV type thing that will play with. This is Prometheus and Grafana. This is just so we can build more modern telemetry-based solutions in the environment eventually. KLB is our Kemp load balancer. Kemp offers a free load balancer. Kemp has been in the load balancing world for a long time. I've used Kemps, I've used F5s, I've used a bunch of open source stuff, but just stumbled upon the fact that Kemp gives us a free load balancer for home labs, fully featured up to a certain probably bandwidth or number of hosts, and that's what we are load balancing Pi-hole 1 and Pi-hole 2 through, and doing DNS load balancing on them right now. Like I said, there's some goofiness there, but it's cool, and the fact that it's there, I can run an enterprise class tool for free, and the others might do it as well, but I installed the Kemp one just to play around with it. Casa is Casa OS. It's kind of an emerging home OS and has some really cool features. We're playing around with that. Rusty 1 is for Rust, the Rust game server. I'm trying to figure out how to make that work. I have taken 4 shots at it. It doesn't work, but that's another thing. That will be our high resource server. That one takes a lot of resources because it's a game server. But if that ever gets working, it'll be interesting to see how that works in the cluster, to have something that's doing live metrics, live data that I could actually have people in playing the game on and creating real traffic on, and see how it does inside of Proxmox. TailSR is Tailscale's VLAN router. It's what we're going to use inside of the cluster, so we can expose the cluster network to the Tailscale network, and that we have access to all of our stuff externally via WireGuard VPN through the Tailscale platform. If you're not familiar with Tailscale, go check it out. They got a really cool free tier platform that is perfect for home labs and for use cases like this. And then we get into the final 2 here, and then we'll wrap up. UBK 8.1. This is Ubuntu K8s Node 1, and I am building it off of the Ubuntu Core, which is a template. It's how you create kind of a gold master inside of Proxmox. I'm having a lot of problems with it. Either they won't boot when I'm done, or they come up with lots of errors and go into Linux safe mode. But we're going to figure that out. And the reason why is because I'm going to spin up a 5-node Kubernetes cluster. Use Kubernetes extensively at Sauce Labs. I didn't manage it. I know the architecture components of it. I know a lot about it, kind of in general. It's time to deep dive and learn. All of that said, I've got one viewer. I'm not sure who you are. I hope you haven't been too bored, and I hope you found this interesting. Feel free to comment on the stream after the fact. Check me out at staticnat.com. I'm also Josh O'Brien77 on Twitter. It's the primary place to find me as far as social media stuff goes. I'm looking forward to doing more of this with you guys, and I'm going to cut some of this down, and we'll be posting it on the YouTube channel as well. So thanks again. This is the introduction for where we're heading, kind of the grassroots. The next stream we're going to do, I'm going to walk you through what changes need to be made on the network, and in order to go from our kind of 2-node hybrid architecture that we have right now, we're somewhere between this 2-node architecture and this 4-node architecture, and somewhere between this network, which was just a bunch of cables connected to servers, and this network. We're in a hybrid state of this. So in the next stream, we're going to break down how to actually plan for this. What are the things we need to do on the network to pre-position things? What are the things we need to do and access we potentially need to have in case things become disconnected, and so on and so forth. So if you were at a headquarters planning this, what you would have to do for your remote data center to make sure you maintain connectivity and all that stuff. Or if you can't, what do you need to do from the data center and what you don't. So that's going to be the next stream. I'll get some prep for it. Might even do it later tonight. I don't really have a stream schedule at this point in time since we're just starting. But again, all of this to some extent will be reposted. My guess is with very little editing on YouTube, maybe no editing at all, just paste these guys up. And then we'll probably start doing some TikTok content as well that will show like segments of this, 37-second segments or whatever that might seem interesting. But again, thanks. Appreciate it to whoever watched the stream and whoever ends up watching the content later. We appreciate it and talk to you soon.